What's up, you data friends? It's Yanis here and welcome to my channel. This video is video part 1 of the time series models series of videos that I will be running. In these videos, I'm going to go through what is time series models, explain how they work, explain the machine learning process, how to import and install your packages and libraries, what is the problem we are trying to solve. Then we're going to load some raw data into Python. Then we're going to go through the data pre-processing phase, and then I'm going to show you how to run Arima, which is Autoregressive Integrated Moving Average. Then I'm going to show you how to tune your Arima model by finding the best parameters so you can improve the accuracy. And then I'm going to show you how to run Auto-Arima. After that, I'm going to show you how to run Prophet, which is another time series model provided by Facebook. And then I'm going to show you how to run 2+ models together. So this example is how to run both Arima and Auto-Arima together. In the next example, I'm going to show you how to add both Prophet and Regression. So now on the same code, on the same loop, we're going to have 4 models in one go. And at the end, I'm going to show you how to run it on every single country, which is about 230 countries in our dataset. Then, so this is all the output from all the countries. And at the end, I'm going to show you how to combine the actual data with the forecast. And then we're going to export the data both in a CSV and in an SQL database. Afterwards, I'm going to show you how to take your results and predictions and build this Power BI dashboard from scratch. So here we can see all the countries, their actuals, their validation predictions, and their future predictions all the way to 2023. And if we were to select a country, for example, so let's do United States of America, we can see the 4 models and their predictions. We can see the mean square error. So if we were to choose the best model, it was going to be the one with the least mean square error. So that was going to be the regression mean square error. So if I was to do a prediction for United States, I was going to choose this number over here for 2023. I have all 4 models here, and we should expect the GDP per capita of United States to be about 67,000 for 2023. We can do this for any country or all countries together. So if we check India, for example, we can see there is a bit of difference in the models, but we can choose the one with the least mean square error, which is the Arima one. So that's going to be the green one. So that's going to be this one over here. So we should expect an increase from 7,000 into 10,000 GDP per capita for India in 2023. Right, and before we start this tutorial, if you're new to my channel and you're passionate about data science, please consider liking this video, subscribing to my channel, and enabling notifications for my future videos. Right, so let's start. What is a time series model? So time series are series of data points listed in time order. So if we go over here, just to show you an example, time series is when we have a series of dates. So you can see here it starts from 1990 all the way to 2008, and we have some values. Then we take these raw data, we feed it into a model, and we get a value prediction for each date, or we can forecast going forward. So if I go back again, time series forecasting is the use of a model to predict future values based on previous observed values. And then the process is similar with the machine learning process, but the inputs are limited to 2 inputs. As we have shown here, we only have date and value, and we predict going forward. So if we go through the machine learning process quickly, we start with the problem formulation, we gather the raw data, then we do our data pre-processing, and then we have to split the raw data. So this is where we take the split. As you can see in this example, we have the mobile sales per month and year. So we split the data somewhere around here. Then we select and train our model based on this data. So these are X-train all the way until here. Then we do the model evaluation. So we predict, which is the red dotted line. And then based on a metric, so we're going to use mean square error, we are going to evaluate our model, and then we are going to do parameter tuning. So we are going to adjust some of the parameters so we can minimize the mean square error as much as possible and improve our model. After we are happy with our model, we are going to run our final model. So we're going to use all the data from here to September 2021 to train the model, and then run a forecast on the future, which is going to be this dotted line over here. Right, moving on, we have our packages and libraries. So we're going to be using all the main ones, so operating system, NumPy, Pandas, Matplotlib, and Seaborn. Additionally, we're going to be using from stats model the Arima one, from sklearn the linear regression libraries. For these libraries are for the Auto-Arima, this is for Prophet, and some additional libraries for daytime. So if you're missing any of these libraries or packages, you can run pip install and then the name of the library, and that's going to install it on your PC. Right, moving on is the problem formulation phase. So here we need to ask the question of what we are trying to solve. And the answer is that we want to forecast the GDP per capita per country for the next 7 to 10 years. So that's what our time series models are going to be forecasting. Moving on, we need to load our raw data. So here I load the raw data from an SQL server, but for you, I'm going to be providing you a CSV file where you can load the raw data from a CSV file. So I'm going to have the links in the video description below. In order to load the raw data now, all you have to do is say raw data equals pd.read_CSV. Then in here, you're going to need to paste the path where you have downloaded the raw data, and also at the end, add the name of the file and a .csv. Also use encoding as Latin/1, and this is going to load the raw data from Excel. So this raw data is going to load it into raw data over here. Then what I do here is that I print the shape of our data. So our shape is 270,000 observations and 8 columns. And I also print the head of our data frame. So you can see we have all the columns and the first 5 rows of our dataset. Right, next we need to go through the data pre-processing phase. So the first thing I always do is check for null values. So by adding our data frame here and then saying .isNull.sum, we're going to see the number of rows that have null values. By the way, I'm not using this raw data. I am using the SQL raw data, but both of them are the same. One of them comes from SQL, the other one comes from a CSV. It's exactly the same data frame. Anyway, as you can see, we have about 2066 null values in value. So in here, so we need to investigate this. However, what I did is that I went straight for the delete because I know that these null values do not come from the GDP per capita indicator that we are going to use. And just to show you how to investigate this, to investigate the nulls, we can write this query. So we can add the value and then say .isNull. So this is going to return all the rows that have a null value in value. However, I only want to investigate the indicators. So if I add the indicator in here and then also say .unique, we can see the unique indicators that have null values, and the GDP per capita, which is this one over here, GDP per capita, PPP, current international dollar, doesn't have any null values here. And this is why I drop the null values straight away. As you can see, SQL.drop NA from the subset of values. And then I also removing the last 2 columns. So these 2 columns that are full of null values and I don't need. Then I check again for null values and I don't have any null values. The next thing I do is a standard piece of code that I always run to investigate all the elements within each feature. And what this code does is that it goes through every single column from our data frame and it prints out 2 things. either the number of distinct values, so 35 distinct values, or the actual elements within the column. So if I change this number of values to, let's say, more than 36, so it's going to pass the threshold, it's going to print all the demo IDs and all the indicators. So if I run it again, you can see now it says the number of values for feature demo int is 35, and then it prints all the 35. So 1, 2, 3, 4, all the way to 35 distinct demo IDs. And then it does the same for the indicator. So it prints all the 35 indicators up until here. So these are all the indicators. And then for the location, country, time, and value, it just prints the number of distinct values in those columns. Right, moving on, the next thing I do is that I am just selecting everything from my data set where the indicator equals GDP per capita, PPP, current international dollar, as this is the only thing I want to forecast going forward. Additionally, I also exclude a few countries from our data set. The reason I'm excluding them is because they have some problematic data that I have identified later on this analysis, but just for ease of this tutorial, I'm just deleting them from here. So the way to delete them is actually run the same code where you say .escene, but if you add this symbol at the beginning of your data frame, just before you run the escene, is actually going to exclude them. And then I'm passing it back into this data set. So if we run this, we get the same columns as before. We have above here, but now we only have one indicator. So in indicators, before we had multiple indicators, now we only have indicators equals to GDP per capita. The next thing we want to do is to limit the data to the columns we need. So we only need country, which is this one, time, and value. So what I'm doing is that I am passing these three columns back into our data frame. So you can see we limited the data. The next thing we want to do is to change the time to date. So change this column to be an actual date, as most time series models require a date structure. To do this, I'm just taking the time, I'm making it a string, and then I'm adding the .01 and then the .01, as you can see it over here. And then I'm taking this column as it is, so now it's a string, remember, and I'm passing it into a pd.toDate time, and then I'm passing into toDate time the forecast time. So now this time is actually a date and is actually a date time. The next step now is to split our raw data into xtrain and xvalid. Our xtrain is going to have all the data before 2012, and our xvalid, which we're going to use for validation and evaluation, is going to have data after 2011. So just to visualize this, because we do have the output, if I go over here, imagine that I am splitting, so this is just India, but I'm doing this for all countries. I am splitting all these GDP up until here. So imagine I'm putting a line here, and then I'm selecting all of this for training data. And then from here, 2011 all the way to 2017, the green line I'm going to use for a validation dataset, which is exactly what I'm doing with this code over here. And if we print the two shapes, we can see that our training has about 3,966 observations, and our validation dataset has about 1,322 observations, and both of them have three columns, and the columns are country, time, and value. Right, moving on, we are going to run Arima, which is auto-regressive integrated moving average time series forecasting model, and we are only going to run this on one country for now, just to simplify things. A few notes on Arima now. Arima uses a number of lagged observations of time series to forecast future observations, and it takes as inputs and parameters the B, which is the number of lag observations in the model, which is also known as the lag order, and this is the AR, so the autoregressive. The D, which is the degree of difference, which is the integrated, and the Q, which is the size of the moving average window, which stands for MA, which is the moving average. If you want to learn more about Arima, you can follow this link and read more about the math of Arima and how everything is calculated. I'm not going to get into it just because this tutorial is more focused on applying it rather than explaining it. Right, so the first thing I want to do is to create two new subsets of data that have data only for one country, and I'm going to use Australia as an example. So I create this AU. So if I copy this quickly, I run it and paste it, you can see that we only have data for Australia in this data frame. And I also create the AU2, which is just the time and the value for this data frame. I repeat the same process for our validation data set because I'm going to use these two to validate our results. Then what I do over here is that I set the time into an index. As you can see, time is now an index. You have to do this to run time series models. And the last thing I do is that I create an index for 7 years going forward. So as you can see over here, the index I'm creating, it's a range from the AU2 index -1. So it takes this AU2 index -1. It means that it's going to take this, the last value, and it's going to use frequency as AS, which is an annual frequency, and it's going to use 7 periods. So it starts from here and it adds 6 more years, as you can see, from 2011 all the way to 2017. The reason I've done this is that I'm going to use this index to make predictions, to use it as a forecasting input. Right, the next step now is to run Arima with just some random numbers. So I call the model Arima, and then into the model I feed the AU2, which is the AU2 we created over here. I give a random order of 200. So 2 is actually the autoregressive. So from here, the 0 is the degree of difference. So the 0 is my I, and then the last 0 is the moving average we have from here. And then I feed my model with discrepancy equals -1. Then I create some predictions. So I call my model Arima underscore feed dot forecast. I want to forecast 7 data points, and I want to take the first row. Then I'm passing the same index as the index I've created into my forecast. So just to run it bit by bit to show you, let me just create this. If I copy this and run it, so my forecast now, if I copy my forecast, is just 7 numbers without an index. And then if I run this, it means that I'm going to pass this index I've created of those 7 days into my forecast. So if I run this now, you can see there is an index on my forecast. And the last thing I do here is that I plot my predictions. So I initialize an empty plot with this line of code. Then I pass a line plot, which is this blue line over here. X, I'm using time, Y, I'm using value, and data, I'm using the AU, which is the first one, not the indexed one. And then I'm setting the title into AU, and then I'm creating 2 additional plots, which is 2 additional lines. The first one is the red one, which is my AU color. Sorry, yeah, the red one is the forecast because I'm doing forecast 1.plot. So red is the forecast and blue is the actuals. So as you can see, we haven't done a very good job as our prediction is going plateau while the actuals is still going up. And the last thing we print is the root mean square error. It's actually the mean square error, not the root mean square error, which takes as inputs the actuals. So this is the comes from valid, from the validation over here, and then the values. Then it compares them with the forecast values. It calculates the difference. It takes the mean and then it squares the mean, but I'm not squaring the mean. It's just the mean now. So what this is telling us is that our predictions from our current model are off by $3,130 on average. The next thing we have to do now is to try to improve our model. And to do this, we have to try multiple different combinations in this order over here. One way of doing it is this piece of code I have down here. So what I've done down here is that I've created a range of P, D, and Q from 0 to 5, and then I pass the dot product of this range 0 to 5 into a list. So just to let you know what this is, if I copy it and paste it down here, is all possible combinations from 0 to 5. You can see I keep scrolling. It's not actually 5 because it starts from 0, but it's 5 different numbers and all their possible combinations. So the dot product. So what I do here, I say for parameter in PDQ, I try to feed Arima again on the same data set and passing the first order, which is going to be this order. Then I feed the model and then I call the AIC. So the AIC is the Akaige Information Criterion, which is an estimator of in-sample prediction error and thereby relative quality of statistical models for a given dataset. So what it means is just a metric that evaluates how good your fit is. And it works like the mean square error. So the smaller the number, the better it is. So what this code did now, if I run it, it goes through every possible combination and it prints this AIC. And what we have to do now is to choose the combination with the minimum AIC, which is this one, 0, 2, and 3, as you can see, is the minimum. You can also see that we don't have all possible combinations, and this is because Arima is not going to work on all possible combinations. So for example, 444 is not here, and if I put 444 at the top, it's going to throw me an error. There you go. So you can see D more than 2 is not supported based on the data set we currently have. So what we need to do now is to try this combination, the 0, 2, 3. As you can see, it gives us the lowest value. So if I go at the top and I do 0, 2, and then 3, and if I run this, you can see we have a much lower mean square error, and you can see our prediction is much closer to the actuals. The challenge now with this method is that we have only done one country, which is Australia, and different countries are going to have different optimal parameters. So imagine doing this, repeating the same process as we've done here, 189 times, which is the number of countries we have. It's not very efficient. So this is where Auto-Arima comes into place. If I scroll down here, is the second option where we have the Auto-Arima model. So to run Auto-Arima is very similar with the Arima. So you just call the model, you feed the same data in, you say if there is seasonality or not. In our case, because it's GDP per capita, there is no seasonality, and then you have to set the M. Now the M is a bit challenging because if you read about what is the M parameter relates to the number of observations per seasonal cycle, and that is one that must be known from before. So because we don't have any seasonal cycles for GDP, as far as I know, I'm going to try with 7, and I'm also going to try with 10 and 15. Remember, we use years. So if I run this with 7, by the way, everything else is exactly the same as before, the previous code which we have just explained. You can see that 7 is not giving us a better model than the one we have identified. Then if we try 5 maybe, so 5 still is not as good. If we try 10, still not the best. So I'm just going to leave it at 7. And my main point here, why I have both Arima and Auto-Arima, is that you cannot be certain that Auto-Arima is going to pick up the best parameters. My conclusion is that you have to run some auto ones. So when I say auto, I mean manual ones, find the best parameters, and at the same time run the Auto-Arima just to compare the two together, which is something I'm going to show you later on when we combine all the countries and the models together. Right, data friends, I'm going to stop this tutorial here and finish the rest of this series in the next video. So I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, please click the like button, subscribe to my channel, enable notifications for my future videos. And if you have any questions, please let me know in the comments below. Otherwise, thank you very much for watching this, and I'm going to see you in the next video.